find out what the frequencies are. Okay, for the first one, from the time 0 to 1. 0 to 1, this is a frequency density graph. In order to find the frequency, I need to take the density multiplied by the class width. What is the density from the graph? Simple question. What's the density from the graph? Aiman? 5. What is the class width? What is the class width from here to here? 1. So 5 times 1 is 5. That's how we get 5 over here. Get it? Now the next one. What is the frequency density? What is the frequency density for the range of 1 to 2? Obviously 6. Then what is the class width? 1 again. 6 times 1, the area will be 6. So next one. You think about it this way. Instead of asking you for the frequency, they're asking for the area. Okay? So what is the area from 2 to 3? Come, mental sums. How much is it? How much is it? Are you with me, class? Yes, how much is it? 4. I heard 4. No, next one, slightly trickier. How much is it? 6 or 3? 6, yes. Because 3, that's the height, 3 over here, times 2 to get 6. Okay, very good. That's the area. Then the final one, it says from 5 to 8. The range is from 5 all the way until 8. But what is the height that I should be drawing? What do you think? What is the frequency density now? 2. How do you get 2? How do you get 2? 6 divided by 3, yes. Why 6? Because 6 is supposed to be the area. 6, which is the frequency, is supposed to be the area. So the area divided by the class width of 3, we obtain density of 2. Okay? So this is what we have for the last rectangle. We can also use our formula. Density is frequency divided by class width. So density equals to frequency of 6 divided by class width of 3 to get 2. Of course, you must be using a ruler. Okay, so next one, exercise number 8. Here we have the mass in grams of some apples. Normally when we want to count and you want to group the sizes of apples together, normally will we choose the equal class width? Will we say from 20 to 25, then from 25 to 30, 30 to 35, 35 to 40? Normally we do that, right? Or maybe we choose from 20 to 30, 30 to 40, 40 to 50. We usually choose equal class width. But in this case, did they do that? Let's just check the class width for this. We've got 15 over here, right? 35 minus 20 is 15. 45 minus 35 is 10. 60 minus 45, 15. 80 minus 60, 20. I do not know why this person wants to group it this way. Regardless, since the person decided to group it this way, we shall use it. So we are expecting the class width to be different. From 15, then it becomes smaller to become 10, then become bigger 15, then after it becomes 20. Okay? And we've got the instructions. 5 squares to represent 10 grams. For the horizontal axis, 5 squares to represent frequency density of 0.5. Draw a histogram. Okay, so I've got my horizontal information already, which is the masses. Vertical information must be the frequency density. So include one more row over here. A third row for your table. Now this is for frequency density. What is the first frequency density that we are going to have? Equals to frequency divided by class width. Okay, so how much is it? Frequency divided by class width. Somebody with a calculator, please check. No. 20. 20 divided by 15. How much is it? 4 over 3. Okay. We take the frequency divided by class width. What about the next one? What is the working? 15 divided by 10. So we get 1.5. Next. 30 divided by 15, right? So we get 2. Next. 10 divided by 20 and we get 0.5. Now we have our frequency densities. We are ready to plot. Okay, so I believe there's enough space. 5 squares to represent 10 grams. We need all the way until 80. 10, 20, 30, 40, 50, 60, 70, 80. Okay, density. Okay, so use your ruler. This will be our mass in grams. Vertical axis. This is our frequency density. Right, so the mass from 0, we've got 10, 20, 30, 40. Okay, all these are basics, you should know already. 5 squares to represent 0.5. It's 1. Okay, so next we have to draw in our rectangles already. For the range of 20 to 35. 20 to 35, the frequency density is 4 over 3. Now 4 over 3 might be difficult to visualize where exactly it is on this graph paper. So we can change it to a decimal 1.3, recurring 1.33333, right? So this being 1, this must be 1.1, 1.2, 1.3 plus a little bit. Okay, this is our 4 over 3. And this is for the range of 20 to 35. 30 being here, 35 must be here. So you should be using your ruler. Okay, this is our first one. Next, from 35 to 45, we've got exactly 1.5. Okay, that's straightforward. You see that the second rectangle is thinner because the class width is smaller. But does that mean the frequency is higher? No. How do we tell the frequency from a frequency density graph? Area. We look at the area, okay? So I think it's quite clear that the first area is bigger than the second area. The next, we've got another range of 15, class width of 15. So 45 to 60. This time the frequency density is 2. So let's extend it up onto 60. And the last one, from 60 all the way to 80, we've got a density of 0.5. This question is, this information is about the marks of 76 students in a mathematics test. So the marks should range from 0 all the way to 100, right? Or probably in this case 80, isn't it? Because somebody who doesn't attend the paper should logically get 0. Okay? So all these 76 students, actually what is the lowest possible mark that they scored in this case? Based on this information, it was just 30, right? So I can safely say that everybody studied at least a little bit lah. They know a little bit of what they are doing. So if I were to plot my graph this way, from 0, 10, 20, 30, 40, so on and so forth, all this portion over here, would you agree that they are wasted space? Is it wasted space? Yeah, because there's nothing there, right? There's no information there. So we don't want to waste paper, what should we do? Yeah, we want to start from 30, right? How then do we start from 30? How do we show them that we are starting from 30? What do we draw? Remember what we drew? We try and compress it together, right? I don't want the blue color part, I want to squeeze it together. So when you squeeze them together, it crumples, right? So it crumples and therefore it looks like this. So it's now crumpled up. Okay? So can you please include the crumpling over here? To show me that, hey, it's not, I didn't make a mistake. I purposely choose to start from 30. Because I don't want to waste the space over there. Okay, so now from 30 to 40, frequency being 12. And next, 40 to 50, we've got a frequency of 15. Then 22. Easy stuff. 60 to 70, we've got 15. 70 to 80, it is 12. Okay, so this should be our histogram. Part A is done. Write down the class width of each class. Do they all have the same class width? How much is it? 10. With the units will be marks. Okay, percentage of students who scored more than or equal to 50 marks. Who are these people? More than or equal to 50 marks? Let's shade on our graph. I think this will be the people who got 50 or more. So the percentage, I will be required to count. I can either count from my graph or I just use the information over here. 22 plus 15 plus 12 divided by total number of students, which is 76, times 100%. And we get exactly 64 and 9 over 19%. Right? Write down the number of students who scored more than or equal to 40. So you must understand the requirements are more than or equal to 40. But less than 60. More than or equal to 40 is over here, but less than 60, so we only include these two portions. And we can tell from our graph or from our table, it is corresponding to these two values. So total of 37. Fraction equals to 37 over 76. Cannot be simplified. Do we need to shade the graph? No need. Now part E, same 76 students in an English test. And these are the results. Find the percentage of students who scored more than or equal to 50. So more than or equal to 50, this must be what I'm looking for. So the frequency over here, 15, 13, and 10. Percentage equals to 15 plus 13 is 28 plus 10, 38 over 76. That's 100%. So we get exactly 50%. Which subject did students have a better performance? So we've got maths and we've got English. Where did they perform better? Why? Why do you think so? Because they like maths. Huh? Why do you think they did better in maths? We talk about the number of students who passed, right? 64 and 9 over 19% passed maths compared to 50% who passed English. So next, comparing the distribution. Okay, I give you some time first. So these are all the observations that we can have from here. So this exercise over here, exercise number 1, this is what your stem and leaf diagram is going to look like. First, you are given a stem. Okay, it is always labeled stem. And we have leaf. Then you've got this horizontal line separating the horizontal line separating your title from your data. Then you've got a vertical line over here separating your stem from your leaf. Okay? So like I said, it is important to know which leaves, where the leaves belong to. Okay? So we see that for stem number 2, what are the leaves that it has? 7 and 8. Intuitive. Can you imagine that there is really a stem with a leaves 7 and 8 growing out from it? Okay? Just need to know that for stem number 2, it has leaves of 7 and 8. What does this actually mean? Look at the key at the bottom. This is the key to understanding what the numbers mean. Okay? So when I have 2 with a line 7, it represents 27 years. Okay? So this information over here is the age of 20 employees of a bank. So based on my key, I can say that there is one employee who is 27 years old. Okay? Can you tell me whether there is an employee whose age is 28 years old? Yes, there is. This guy is 28 years old. So from the same stem, the stem of 2, there is a leaf 7 to give us 27. From the same stem of 2, there is another leaf that says 8. So we've got 28. Okay, if I were to list down all the ages of the employees, I've got 27, I've got 28, right? Can you tell me what is the next smallest age? 31? Okay, over here 31. Okay, what is the next age? 33, then 34, then 35, next. Oh, same age, is it? Is it the same age? Yes, it is. Okay, 2 people are age 35. Next, 37, 38, 39, 40, 42, 42, 42. It appeared 3 times, right? Is this the highest frequency? You just quickly look at the stem and leaf diagram. Is that the highest frequency? So immediately you must know that that is the MO. That is the mode. Okay, so if it is one number, it's called the mode. Okay, so we know that this is the mode already. Very easy. Next, after 42, what do we have? 43, 46, 49. Then? Is it 50 or 60? 60. Is there anybody who is 50 something years old? Don't have, right? If there is somebody who is 50 years old, we will see this. But there isn't. There isn't any. So next one will be 60, followed by 61 and 63. Can you count how many numbers there are over here? How many do we expect? We expect 20 because 20 employees, right? So we got 4, 1, 2, 3, 4, 5. Yeah, I've got 20 numbers over here. So this is how we represent the information in a stem and leaf diagram. I could give you a whole bunch of 20 numbers over there. You see already, your eyes also blur. But if I represent it in a stem and leaf diagram over here, it cuts down on the amount of numbers that we have to write. So instead of writing 40, 42, 42, 42, 43, 46, 49, I just write 4, 0, 2, 2, 2, 3, 6, 9. Makes things a bit easier. Okay? Okay, now we are ready to fill in the blanks over here. So stem and leaf diagram. It shows the shape of the data according to the data values. Okay, based on the numbers, we get the shape of our stem and leaf diagram. So obviously it is split into 2 parts, the stem and the leaves. Okay, plural leaves. The leaf of a number is usually the last digit. Does this make sense with what we have seen in our example? The leaf is always the last digit, whereas the stem must be whatever is left. Okay? Whatever is left of the digits. So for this particular example, our stem will be the 10th digit, our leaves will be the 1st digit. Okay, let's see how fast we can do this. Part A, answer. 63 years old. Part B, 27 years old. Part C, 42 years old. And the last one, in their 40s, what does that mean? That means 40 something, right? We got 1, 2, 3, 4, 5, 6, 7. So percentage is 7 over 20 times 100% to get 35%. Okay, now average age. Okay, this one you need some time, right? Average equals to, then you add everything up, something plus divided by 20 people, we get a total of 825 over 40, which is 41 years and 3 months. Okay, don't need to fill this up because I'm sure you know how to calculate average. Okay? Thank you. Okay, next, now that we know how to interpret the stem and leaf diagram, we want to construct the stem and leaf diagram. Do you think it's going to be difficult? No. I think it's quite easy, right? So what is the first stem that we should have?
3.
How do you know it's 3? Why not 2?
What is no 2?
Oh, okay, very smart. So the first stem will be 3. What is the first leaf then? 1, 0, 4. Okay, so we are talking about the first number, right? Strike it off so that you don't repeat it. Is there another 34? What about the next one?
5.
Okay, 5. Strike it off. Then we have only 1 5, is it? Okay, then next one will be 6. Any more? Yeah, looks like that's it. What is the next stem? 4. 4. Do I have 40? Nope. Okay, 41 only. I see a 42. Any more? You look at how I'm writing it. I try to put everything in neatly in columns. Okay? Because one of the advantages of our stem and leaf diagram is that when we look at the distribution, when you look at this, I can tell that most people are 30 something years old. Can you see that? Oh, sorry, not 37. Yeah, this is the age. Most people are 30 something years old. Nobody is 50 something years old. Very few people are 20 something years old. And I can say that because all the numbers are arranged very neatly. If your space between the numbers sometimes big, sometimes small, are very hard to tell. Okay, and I think some of you are not listening already because you think it's so easy that you're actually doing it yourself. Fine. So I've got 41, 42, because this is really easy lah. Any more? 40 something? Where? Oh, there's another 42 over here. What else? 43. Any more? 45. Any more? No, okay, next number, 5. 53. 53. 54. 54. 56, yes. Okay. Any more? 59. So, okay, let's pretend I didn't see this 59, okay? So I think it's like that. Then next one will be 60, right? 60 something, right? So I've got a 60. I've got another 60. I've got another 60. I've got a 61. 63. 65. 68. Okay, next one will be 72. 76. And 77. Finally, I've got a 80 something. 85. Okay, now that I'm done with this, then look at my table again. Oh, I missed out one, right? I missed out 59. See, this one was not cancelled. That's why it is useful to cancel, especially when you have so many numbers like this, you may miss it out. So okay, let's insert 59 back. So it must lie here. Huh? Did I miss anything else? What if you miss the one in the center? Then you have to erase and then you arrange them again. Okay, so try be careful. Okay, next, after you have your stem and leaf diagram, you still need to put in the key so that people understand. Do you remember what the previous key looked like? 2/2-7 represents 27 years. Did they randomly choose a 27? Actually, they did but it just so happened that it is the first number, right? Why not standardize it? Let's just always use the first number. Don't need to think so much. What's the first number? 3-4 represents 34. What is this supposed to be? Kilometers per hour. Easy? Okay, now find the range of the speed of cars at a junction. Range. What is range equals to? We take the largest number, 85 minus 34, and we get 51 kilometers per hour. Okay, now part C requires some understanding and some thinking. If you exceed 63 kilometers per hour, you are fined for over speeding. Exceed, you must know what exceed means. So, if I travel at 62, am I speeding? 64, am I speeding?
Yes.
63, am I speeding?
No.
63 one more time, am I speeding? No. Okay, 63 not speeding because they exceed. More than 63 is over speeding. Okay, so 63 is not counted. How many cars are fined? Where are the people who overspeed? So these are the people. Agree? Okay, so percentage of cars, that will be percentage equals to 1, 2, 3, 4, 5, 6. 6 divided by how many cars altogether? 25, you counted, is it? Okay, divided by 25 times 100% to give us 24%? Yes. Okay. Next, when we see this question very frequently, describe the distribution. We always talk about the range, okay? It ranges from, the smallest will be 34 kilometers per hour to 85 kilometers per hour. We can also talk about clusters. Okay, out of all these stems, right, which one has the highest numbers? Out of all the stems, 3, 4, 5, 6, 7, 8. Which one? 6. Okay, so they cluster most. Am I right to say that most of the cars are traveling at 60 something kilometers per hour? Right? Most of them are traveling at 60 something. So it clusters at around 60 something. Okay, so the 60 something will be from 60 to 68. Okay, so listen carefully. They cluster from 60 kilometers per hour to 68 kilometers per hour with a peak, or you can say with a mode of 60 kilometers per hour. Okay, they cluster from 60 to 68 with a peak or with a mode of 60 kilometers per hour. The first stem to be. Keeping in mind, the leaves are the last digits.
1, 2.
What's your stem? 1, 2. Then what is your first leaf?
3.
3. Okay, so you are talking about this one, right? So I'm sure you can carry on. The next stem, what do you think it will be? 13 I think we can continue, right? 12, 13, so on and so forth. Then we also need a key. What is your key gonna be? 12-3 represents 1, 2, 3 cm. Okay? Fill in the blanks yourself. Don't do it now because I want to go on to the next one which you have not seen before. Stem, leaf. Okay, again, our leaf will be the last digit. Our stem will be everything else. The difference between this data set and everything else, what is the difference? Yeah, there's decimal. So how are we going to deal with it? How shall we deal with this? So the last digit again, right? Last digit will be the leaf. Everything else is the stem. What is the smallest number that we can see over here? Smallest number of all the 70 somethings. 75.0. Okay, this is the smallest number. So I have a leaf of 0 and I have 75 over here. Does this make sense to you? Okay, now in this case, are you tempted to put a decimal point? Would you like to put a decimal point? Would you like to put a decimal point? Actually, you don't need. That's why the key is very important. I can leave it like this, and I say the key shows 75-0 represents 75.0 grams. Understand? So in this case, I don't have to put decimal points everywhere. So obviously the next one must be 76 and 5. So this done, then 77 with 0, 77 with 3, then 4, then 8 and 9. Then you fill in the blanks yourself, okay? Exercise number 4 now. I just want to point out one error in the printing. This means, what do you think this means? 1 dash 2. What does it mean? Nope, in this case it means 1.2 cm. Okay, please change the question. It's meant to be 1.2 cm. Huh? So do you think you can complete the rest of the notes for this?